Future's network calculations, besides being able to deal with rates and rate constraints, can deal with pressure constraints, with reservoir pressures, with well inflow performance, with tubing performance and pipelines. So with that, you can construct full integrated asset model calculations within Future. And I'd like to give you a brief introduction to this. The calculation scheme in many traditional integrated asset model calculations starts with the pressure calculations and often has an iterative calculation to solve for that. And then there's an outer iteration to apply rate constraints and to calculate the optimal choice of wells to flow. The calculation scheme within Future is different. Future starts with a linear solver for the network, and that's a reflection of the way it started with its focus on rate constraints. And this formulation has been extended to include pressures by having linearisations of the pressure relationships, of the rate pressure relationships, put into the global linear solver. Now, that in itself is not guaranteed to give a proper solution, but Future takes the same approach as the Newton-Raphson method does, namely to make iterative linearisations until convergence is approached, and this is based on the observation that if you happen to choose the right linearization point, if you happen to be linearizing eventually at your solution point, the linear and nonlinear equations have the same solution. So how does Future choose its linearization? What it does is taking the example of the situation where you generally have the biggest nonlinearities, namely the well pressures. Future takes each individual well and makes an estimate of the tubing head pressure. So that can be, typically that's taken from the previous time step. At that tubing head pressure, Future solves exactly the intersection of the nonlinear well inflow equation and the nonlinear tubing performance equations. And that intersection point is the point at which it linearizes the relationship between bottom hole pressure, tubing head pressure, and fluid flow rates. And that's put into the global solver, and then that solver then calculates the effects on tubing head pressure of all the back pressures from this well and from the flow from this well and from other wells. And so in the global solver, it comes up with a solution in terms of optimized rates and pressures. If those linearized pressures are close enough to the exact pressures, then you're done. Otherwise, one can do another iteration. And in practice, the result gives very good results. An example, here is an example of the inflow performance and tubing performance. So the blue is the reservoir inflow. It's nonlinear because it's using the gas pseudo pressure method, and the red is the tubing performance curve, again highly nonlinear. And Future then calculates the intersection of the red and the blue, and then at that point it linearizes them, not exactly with a line, but more with a hyperplane. but this is illustrated in 2 dimensions here. So the green then is the linearization of the blue, and the grey is the linearization of the red. And providing the 2 linearizations intersect at the same point as the nonlinear relationships, then that indicates that the global solution will be coming up with the correct answer for the overall pressure calculations.